Hi friends, how are you all? Hope you all are doing well. So today we are on the exercise 1.2 of chapter rational numbers, class 8 mathematics. But as always, before going up to the exercise, first let us clear a few concepts that are used in the exercise. Okay, so first we will be clearing some concepts and then moving on to the exercise. So the first thing that we are going to cover up is representation of a rational number on a number line. Let me write that one for you all. Representation of a rational number on a number line. Okay, so firstly I have already told you about the natural numbers, whole numbers, integers, and also the rational numbers on the number line. Let us revise that. For natural numbers or counting numbers, this is the number line that we usually follow under natural numbers. So okay, so we got this. We start from 1, 2, 3, 4, 5, 6, 7, going so on. Okay, and now if I come to whole numbers, so what happens in this one? In this one we include the zero, so I would have a number line somehow like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, so on. Okay, and now I'm coming on to integers. Integers include both the negative and the positive numbers as well as 0. So this is somehow represented like this: 1, 2, 3, 4, 5, so on. Coming back, -1, -2, -3, -4, -5, and so on the left hand side. And for rational numbers, I have already told you. In rational numbers, we also include the fractions as well as the decimals that are present between any two numbers and is on the number line. So if I got this 0, 1, 2, 3, 4, 5, so on, coming back, -1, -2, -3, -4, going on the left hand side. So if I take any number, suppose I take this, and this comes out to be 1/2, so it is a rational number, and that is represented on a number line. Similarly, if I take a number, okay, let me guess, let me have, okay, so I got the 2/4, that's half, and then I got 4/4, so 3/4 can somehow be represented out here, because 4/4 is 1 and 2/4 is half, so it comes in between. There are infinite numbers of rational numbers that can be represented on the number line. Now suppose if I take 1/4 to be represented on the number line. So first we will be making a number line. Okay, then I got 0, I got okay, so I got 1, I got 2, and I got 3, and so on. Similarly, out here I got -1, -2, -3, -4, so on. Okay, so if I need to represent 1/4 on the number line, so first we need to divide the gap between the two numbers in 4 equal parts, that are 1/4, 2/4, 3/4, and 4/4. As you already know that 4/4 is 1, so I can just write this one as 4/4. And what is 0/4? That is 0, so I can write this one as 0/4. So I have got 4 equal divisions between 0 and 1 if I need to represent a number having denominator as 4. Okay, so I will be dividing it into 4 equal parts. I got 4 by 4 at the end because that counts as 1, and here it is 0. So this one comes out to be 1 by 4, and this one comes out to be 2 by 4, and the last 3 by 4. So we got 1 by 4, and here we can also see that 2 by 4 when simplified gives us 1 by 2, and 1 by 2 is the midpoint of 0 and 1. So that comes out to be 50%. Similarly, if you see for 1 by 4, when we divide it, we get 25% of a thing. We are given 4 equal divisions between the two numbers, and that's how you represent a rational number. Okay, let me give you one more example. Suppose, but there is a thing that you need to keep in your mind, that if you are given, let me write, if you are given 1 by 8, you need to make 8 equal divisions between 0 and 1, or between any number that you take. If you take 1 by 8, then you need to make divisions between 0 and 1, because we see that 1 by 8 is greater than 0 by 8, but is smaller than 8 by 8. So that lies between 0 and 1. So that's how you take out whether the number is between 0 to 1 or 1 to 2, or between any two basic numbers. Okay, and let me make a number line. I got 0. If I need to do it for 8, I need to, if I have 8 in the denominator, then I need to make 8 equal divisions between the two numbers. And here we see that the 1 by 8 lies between 0 and 1. So I need to make 8 equal divisions between 0 and 1. This one is 1, and here we come minus 1. So for the 8 equal divisions, we just start 2, 3, 4, 5, 6, 7. Okay, so we are done. Let me get one a little bit closer. So this is your 1. So now let's start counting. First with 0 by 8, that is the 0 itself. Then we got 1 by 8, then 2 by 8, 3 by 8, 4 by 8, that is 1 by 2, 5 by 8, 6 by 8, 7 by 8, 7 by 8, and at last you have 8 by 8, that is 1. So here we can see that 1 by 8 is here. You can just mark this point like this to identify the number, that is 1 by 8. And similarly, if I try to do for minus 1 by 8, let me do that for minus 1 by 8, so that you are also familiar with the left hand side to find out the rational number. So if I take minus 1 by 8, again we need to make 8 equal divisions between 0 and minus 1, because the number lies between 0 and minus 1. So I got 1, 2, 3, 4, 5, 6, 7. I got 8 equal divisions out here. So I will be naming them like, this one is minus 8 by 8. Okay, and this one is 0 by 8. So as you can see that we have increased on the left hand side. So the numbers would go decreasing if we start from the right hand side of minus 1, and would get increasing but actually decreasing, because the more is the negative number, the more lesser is the value. So if I go on to the left hand side, the number would start decreasing. So now let's start with this. I got minus 1 by 8, minus 2 by 8, minus 3 by 8, minus 4 by 8, that is minus 1 by 2, minus 5 by 8, minus 6 by 8, and I got minus 7 by 8, and at last I have minus 8 by 8. So if the question asks to find or to determine minus 1 by 8 on the number line, then here you go, you got minus 1 by 8. So that's how you represent. If you take any number, let me take 5 by 7, let me take 4 by 9, let me take any of a bigger number, I can have 4 by 16. So that can all be represented on the number line. We just need to look on the denominator, make that much equal parts between the two numbers. For 5 by 7, let me give you a clear understanding. Okay, so we know that 0 by 7 and then is smaller than 5 by 7, but 5 by 7 is also smaller than 7 by 7. So this one lies between 0 and 1. This one lies between 0 and 1. Similarly, if I look for this one, this would somehow go 4 by 9. So this one would lie between 0 by 9, 4 by 9, and at last it lies between 0 and 1. For this one, it also lies between 0 and 1 because the numerator is smaller than denominator. But what if the numerator is greater than denominator? Suppose, let me take 17 by 8. What happens in this case? Not to worry about. We first take 0 by 8. Okay. So, for 0 by 8, it is greater than 0 by 8. And this one is, as you can see, you can also see by dividing it. Suppose if I divide 17 by 8, I will be getting 2.125. Okay, so I will be getting 2.125. So this clarifies that the number is the number is lying between 2 and 3 because the number says 2.125. Okay, so we have a number little greater than 2 but less than 3. So the number lies between 2 and 3. Similarly, you can do with this one. How? This would come out to be point. Okay, so let me do this one for you. I will be doing it. It will come out to be 0.4 bar. Okay, so it will be 0.44444. So as you know, okay, so I need to show you in this one. So as we know that 0.4 is greater than 0 but less than 1. So it lies between 0 and 1 as we have observed out here. So that's another way to take out where does it lies on the number line. Is it between 0 or 1 or between 2 or 3 or between any two numbers? And there is one more case out here. Let me discuss it with you all. If you have 4 by 16, then that will be very difficult to make 16 equal parts between two numbers, and that is time consuming too. So what you need to do is, this is a rational number itself, but if we simplify this one, this would come out to be 1 by 4. So you just need to make 4 equal parts, and that can also be same as 4 by 16, and that is a rational number too. So with whatever rational number that you try, either you try with 4 by 16 and 1 by 4, both would be correct because both are rational numbers and both can be represented on the number line. That lets us to another topic, the rational numbers between two rational numbers. Okay, so let me again mark that one for you. Rational numbers between two rational numbers. Suppose you are given any two rational numbers. Let me take 1 and 2 only because they are rational number 2. So if I take 1 and 2, so how many rational numbers can I have? Okay, so first let me start with natural. How many natural numbers can I have between 1 and 2? That's none, because the natural numbers are counting numbers and there is no counting number between 1 and 2. That's in halves, but that is not valid in the counting numbers. Similarly, if I say you that how many whole numbers are there? Let me take another example, that if I gave you 1 by, okay, so if I gave you minus 1 by, minus 1 and 4, and if I ask you that how many whole numbers are out here, you will be saying that there will be 0, 1, 2 and 3. Well, that's correct. But if I say you that how many, if I turn that one in 4, 2, and if I ask you that how many integers are present between minus 4 and 4, you will be saying that there will be minus 3, minus 2, minus 1, 0, 1, 2 and 3. Well, that is correct too. But if I come on to the rational numbers and I ask you, even between, I will be asking you, tell me how many rational numbers are there between 1 and 2. So there are infinite rational numbers between any two rational numbers. Okay, so minus 4 and 4 are rational number 2, so there are infinite rational numbers. So let us see how many rational numbers can be formed between 1 and 2. Okay, so let me take an improper fraction. Okay, so if I take 14 by 8, I can further simplify this one. That comes out to be 7 by 4. And what would be the decimal form of the fraction, they will come out to be 1.75. So I got a 1.75. So this determines that the number lies between 1 and 2. 1.75. Okay. Similarly, I can take many of the numbers. As you can see that there are infinite decimals between 1 and 2. That implies that there are infinite fractions. Because I can take 1.662 and I can take 1.08972099816. That is a rational number too, and that do lie between 1 and 2. If I take any of the fractions, okay, let me start with fractions. So let me take any of the bigger number. Let me start with the denominator 8. So if I make a number line, I got 0 and I got 1 and I got 8. 1, 2, 3, 4, 5, 6, 7. So I got 8 divisions, 8 equal divisions between 0 and 1. But are there only 8 equal divisions? No, we can do with 9 too. We got 9. And that the number do lie between 0 and 1. Okay. And there are many of the numbers. If you take numerator smaller than denominator, the number would obviously lie between 0 and 1. And you know how many numbers can you take as a proper fraction. So there are infinite rational numbers present. Okay. So if I take 1 and 2, so I know that the denominator are 1 for each. But what if I multiply the denominator and numerator by 10? So this would come out to be 10 by 10 and this one would come out to be 20 by 10. But if I simplify them again, that would again return to 1 and 2. But from here I can see that there are 10 divisions between those fractions. That means there are 10 numbers. But as I've already told you, it's not finite. I can again multiply them with 10. So I will be having 100 and then I will be having 200. Now I have 100 numbers between them. And what if I multiply them with 10 again? I will be having 1000 and then I will be having 2000. So I have 1000 numbers between them now. So you can take out as many rational numbers as you want. And there is a question that arises that the question says that write any 5 rational numbers between 1 and 2. So you need not to worry if your answer is not matching with any of the supplementary books or with the NCERT. It depends because there are infinite number. Any child can take any number. But that should lie in the radius that the number should be between 1 and 2. Suppose if I take 0 by 1000, that won't be valid because that comes to be 0 and does not lie between 1 and 2. Hope you have understood this one. So now let's start doing. As I've told you this method, let me give you one other examples that find rational numbers between 5 by 8 and 9 by 7. So very easy, not needed to be worried. First we need to take out the LCM of these both. That is, what's the LCM for these both? It is 56. So we need to multiply 5 by 7. So I got 35 by 56. And then I need to multiply 8 with 9. So I got 72 by 56. So as you can see that I can write any number between 72 and 35 with the denominator 56. So that comes out to be, I can write any, okay, so let me give you, let me change the question and write 5 rational numbers between 5 by 8 and 9 by 7. So that could be 40 by 56. That could be 41 by 56. That could come out to be 69 by 56. That can come out to be 70 by 56. Also, that can come out to be 71 by 56. Okay, so let me write it again. That might not be visible for you, to you all. So I can also write it 50. So I can write 57 by 56. Also, I can write, well, that's a, we have already found it 5 rational numbers between 35 upon 56 and 72 upon 56. But you can also write 56 upon 56, that comes out to be 1, and that is a rational number too. So that's how you find it. That's a way, And if you are given with only two numbers that have denominator as 1, you can do the same. You need not to worry because there is another method for that. Okay, so if I write 5 rational numbers between 9 and 10. So as I know that I need to find 5 rational numbers, just add 1 to it, that will come out to be 6, and then multiply both the numerator and denominator of the given numbers. Suppose I have given with 9 and 10, so I will be multiplying 9 by 6 and the denominator by 6 too. That will give me 54 by 6. And if I do the same with the 10, so I will be having 10 upon 1 into 6 into 6. That will give me 60 upon 6. So I can see that I have numbers like 55 by 6, 56 by 6, 57 by 6, 58 by 6, and 59 by 6. You need not to cover up these both numbers, as these both are barriers, and if you include these numbers as the rational numbers that are needed to be find out, the answer of you will be wrong, because it says to find the rational numbers between, not including the two numbers that are given to you. So that's the way. If you're given any, suppose I write 9 rational numbers, just add 1 to it and multiply in both the numerator and denominator of the given numbers. But that is mostly applicable if you are given the numbers that have the denominator as 1. And there was one more method I have already told you, that you can just directly multiply them with 10, hundreds or thousands. So you will be getting 10 rational numbers between them, 100 and 1000 respectively. So now let's start with the exercise. Exercise 1.2. Here comes question number 1. Question number 1 says, represent these numbers on the number line. Well, I have already told you the first part comes out to be 7 by 4. Make a number line. Mark 0. Then you need to make 4 equal divisions, and when we divide the number, that comes out to be 1.75. So that indicates that this number lies between 1 and 2, because 1 is smaller than 1.75, but the 1.75 is smaller than 2. Hope you have understood this one. So now if I take, I got 1 out here, I got 2, and I got 3. Same on the left hand side, I got -1, I got -2, and I got -3, and I continue on the both sides. And now it says to represent 7 by 4. So as we all know, this comes out to be 0 by 4, and this comes out to be 4 by 4, and this one is 8 by 4. So 7 by 4 lies between 1 and 2, between 4 by 4 and 8 by 4. So let me make 4 equal divisions. So I have made 4 equal divisions because the denominator is 4. So I need to make 4 equal divisions between any two given numbers. Okay, between any two numbers. So here comes to be 5 by, so here comes to be 5 by 4, 6 by 4, and here comes 7 by 4. So here is 7 by 4. Okay, similarly you have 4 equal divisions out here. Okay, and you got 4 equal divisions. That's how you do it. You got 7 by 4 here between 1 and 2. If you make 4 equal divisions, then that will be the third one. Similarly, moving on to the second part. Okay, second part says -5 by 6. There comes a negative rational number. Okay, so if we see the second part of question number 1, it says -5 by 6. That is a negative fraction. So first we need to take out, first we need to make a number line. So there goes the number line. Then I mark 0. As you can see, we need to make 6 equal divisions, so we need to leave the space accordingly. I got 1 out here and I got 2, and again moving on. Then I got -1 out here and I got -2, and similarly moving on. So by the fraction, you can see that it is a proper fraction. So the fraction would lie between -1 and 0. Why? Because 0 is smaller, 0 is greater than minus 5 by 6, and minus 5 by 6 is greater than 1, or you can say minus 6 by 6. So the number lies between 0 and minus 1. So now let's do this. Make 6 equal divisions. I got 1, 2, 3, 4, 5. Okay, this one is minus 1, the one which is in the box. Okay, and here comes it. Minus 1 by 6, minus 2 by 6, minus 3 by 6, minus 4 by 6, and here comes it, minus 5 by 6. So the fraction that just comes the first to the right hand side of minus 1 is minus 5 by 6 if you have made 6 equal divisions, and that's your answer. That leads us to question number 2. For question number 2, it says represent minus 2 by 11, minus 5 by 11 and minus 9 by 11 on the number line. As you can see that all three numbers are negative numbers, so let me write them: minus 2 by 11, minus 5 by 11 and minus 9 by 11. So I need to make 11 equal divisions first, so the number line might go big. Equal divisions. Okay, so as you can see that all the numbers are bigger than minus 11 by 11 but are smaller than 0. Then the number lie between 0 and minus 1. So I need to make 11 equal divisions between 0 and minus 1. There goes number line. Then I got 0 here. I got 1 out here, and I got 2 out somewhere here. Okay, and then I move on. Let me put this arrow out there. Similarly, if I see out here, I will be having minus 1 here and minus 2 somewhat here, and that's how you do it. That's how you do it. Let's move. So first we need to make 11 equal divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There I go. And then first one I got minus 1 by 11. That is not required. Then I go minus 2 by 11. There it is. Minus 2 by 11. There is the first one. Then I move on to minus 3 by 11. Not required. Minus 4 by 11. Not required. Minus 5 by 11. It is required. There goes another number. And at last you have minus 9 by 11. So this one becomes minus 6, minus 7, minus 8, minus 9. There comes out to be minus 9 by 11. And 1 is minus 11 by 11 itself. So there you go with all three numbers represented on the number line. Moving on to question number 3. Question number 3 says write 5 rational numbers which are smaller than 2. It is very easy. We need to write any 5 rational numbers that are smaller than 2. So the numbers can come out to be integers. The numbers can be, I can have 1, I can have 0, minus 1, minus 2, minus 3. I can have any fraction. I can have 1 by 2, I can have minus 1 by 4. I can have many of them because the rational numbers are infinite. And I can also have minus 40, that is smaller than 2. And I can also have 1.75. Well, there are many of the rational numbers that you can write. So you need not to worry if your answers are not matching with mine, because there are infinite numbers of rational numbers. The answers could be different for different children because we have infinite numbers. Because we have infinite rational numbers. And that takes us to question number 4. Question number 4. Find 10 rational numbers between minus 2 by 5 and 1 by 2. So we are given minus 2 by 5 and 1 by 2. First, let's take out the LCM. That comes out to be 10. So multiplying both the numerator and denominator by 2, we get minus 4 by 10. Similarly, doing that with 1 by 2 into 5, we get 5 by 10. Okay, so from this you can see that we can find only 8. But there is another method that you can do out here. You can easily, as you see that the LCM are same, you can easily apply that you can multiply any number on both the numerator and denominator except 0 to make it a little bit larger, let me take, okay, I would prefer 2. So if I multiply minus 4 by 10 into 2 into 2, then I will get it minus 8 by 20. Similarly, if I do for that side, okay, I will be having my 5 by 10 into 2 into 2. That comes out to be 10 upon 20. So here I got more than 10 numbers, rational numbers. So the numbers can be any. Let me write all the numbers that are present right here. That can be minus 7 by 20, minus 6 by 20, minus 5 by 20, minus 4 by 20, minus 3 by 20, minus 2 by 20, minus 1 by 20. I got 0. Okay, I can have many more like that. I can have 1 by 20, 2 by 20, moving on to 10 by 20. Okay, let's move to question number 5. First part says find 5 rational numbers between 2 by 3 and 4 by 5. First, let us take the LCM. That comes out to be 15. So this one would turn 2 by 3 into 5 and into 5 by 5. That comes out to be 10 by 15. Similarly, if I do with 4 by 5, 4 by 5 into 3, so that comes out to be 12 upon 15. So here we can see that we have only one rational number between them. Well, if you see in terms of denominator as 15, but you can have many more. Like if I multiply into 5, okay, so I can multiply both by 5. So this would turn out to be 10 by 15 into 5 into 5. That comes out to be 50 by 75. Similarly, if I do out here 12 upon 15 into 5 into 5, that comes out to be 60 upon 75. So I got 10 rational numbers between them. You can choose any of the 5 and that's your answer. Okay, then let me move to the second part. For the second part, it is minus 3 by 2 and 5 by 3. So I need to find 5 rational numbers between them. First, let us take the LCM. That comes out to be 6. So I got this one as, okay, so I take this one, the multiplying, I have minus 9 by 6. And then if I do the same with this one, multiplying numerator and denominator by 2, I will be getting 10 upon 6. And again, you can take out any 5 rational numbers between them in respect with the denominator of 6. Moving on to the third part, let me write it here. 1 by 4 at 1 by 2. We get 1 by 4 and 1 by 2. Again, taking the LCM out. Okay, so LCM is 4. So this comes out to be 1 by 4 and this comes out to be 2 by 4. And then multiplying both sides by 5. Or let me take a greater number. As we need to take out 5 rational numbers, we multiply it by 6. So as I have told you, 5 plus 1. So this comes out to be 1 by 4 into 6 into 6, that comes out to be 6 by 24. And here it comes out to be, okay, so it will be 12 by 24. And here you can take out any of the 5 rational numbers. Or moving on to question number 6. So here we go with question number 6. It says write 5 rational numbers greater than minus 2. Well, we were having a condition that less than 2 and now we have a condition greater than minus 2. Again, they can be infinite rational numbers. You can take minus 1, 0, 1, 2, 3, 4, 5, any of the fraction. You can take 5 by 10. You can take 75 by 100. And also we can take any of the decimal numbers. So let me take, I can have 3.1298816. Okay, so there are many of the rational numbers that you can find. And question said to find any of the 5 rational numbers greater than 2, minus 2. That leads us to the last question of the exercise and of the chapter. Find 10 rational numbers between 3 by 5 and 3 by 4. To find out 10 rational numbers between 3 by 5 and 3 by 4, first, what do we need to do? Again, take the LCM. and that would be 20 in this case. So this would come out to be multiplying 4 in both numerator and denominator, we get 12 by 20. And if I do out here, then multiplying 5 on both the numerator and denominator, I get 15 by 20. And again, I can see that there are not much rational numbers that can be shown in terms of denominator with 20, and I will and the question says to find out 10, so I would take 10 plus 1, that comes out to be 11, and just multiply in these. So what do we get? Multiplying 11 and 12, I get 2, 1, and then 2, 1. I got 132 upon then half 220. And similarly, I had 15 and 11. What do we get? We get 5, 1, and again we get 5, 1. That's 165. So we have 165 divided by 220. And again, you can take out any 10 rational numbers that are there in respect to 220 as the denominator. You can take 135, 137, 138, 139. You can go to 140s, 150s, and you can go till 164 because the question says to find between. Okay. So hope you have understood the chapter. That was very easy, but it was very interesting and filled of excitement. I tried myself best to give you the best explanation that you would ever have on this chapter. Now let's meet on the another one.